station-to-station traffic prevention. So basically, because traffic is just sent over the air, you can just grab it and then inject what you want to establish the communication. So the thing is, if I want to talk to a station, I will do it myself without using the access point. So this allows to bypass protection. This allows you to communicate to station within reach, even if the access point is too far to get associated to it. And it allows you to communicate with station if the access point refuses you to get associated. No, for example, if you have a MAC address filtering or something like this. So proof of concept for this is a tool I made with Wifitap, so it will be online in a few hours. So it's proof of concept. So I had an argument with a guy from Cisco pre-sale. So I just wanted to write it to show him he was wrong. So it's written in Python. It relies on Scapy I mentioned before. So basically, it's a tool that allows you to communicate with a station on a wireless network without the access point authorization. So it relies on a tune-type device, so you have no stack to implement, and uses Wi-Fi traffic injection. So it works like this. So it just sniffs networks and then push the frames after I remove .11 headers and push the frame to the tune-type device. And to send frames, I do the inverse. I take the Ethernet frame, add .11 headers, and send them on the wire with the from DS flag set. So when I send the frame, the station accepts it. So I'll try to make a demo. So I hope Murphy is not looking at me. Okay. Okay, so syntax of the tool is quite simple because the So the only thing you need, in fact, is the AP you want to spoof MAC address. So I put a bit bigger because whoops. Okay, easier to see. Okay, so it works in clear text. It can work with WebSet. So knowing the key, we can just inject web frames. That's it. So the things I will do is, so I have only one interface set, it's ETH1, so ETH1 is a Prism 54 interface. It's in monitor mode, okay, so I'm not associated to, I have no hub interface associated to the network. So what I will do is try to communicate with Recon Monet associated stations. So I give the BSSID and then the interface I will use. Okay. So the next thing is configure the interface, the TuneTap interface. So give it an IP on the network, and then finger crossed, we'll try to establish some communication. So the basic, the easy way to do this is doing ping scan. And so we'll see if we can ping someone or get ARP request answered. Okay, so as you can see, my ARP requests, some of them have been answered, and I can just detect some computers up. So I won't go further on the demo because it's not that interesting. The thing that is important to me about this tool is you can just communicate with any station you want, providing it's in your switchable with your Wi-Fi adapter. So that's it. Okay. So it's not online yet, but you will be able to download it afterward. And as you will see, it's a script. It's about 400 lines of code, just like this, and about a third of this is argument parsing. So, suppose you have a hotspot, commercial hotspot with PSPF protection. So the thing is, your only solution to get an authorization is to eject the guy and take its place, because you cannot send him the traffic back. But using this tool, you are able to do this. So that's more ethical, you know. So the guy won't complain and things like this, and he doesn't lose money. So that's it. So okay, it's nearly finished. So now we'll see what we have now to protect Wi-Fi networks. So these are the latest standards. So WPA that was published in 2003, and .11i, which was published last year, and WPA2. So WPA is an extract, so it's a recommendation, not a standard. So the Wi-Fi Alliance, which is a consortium of Wi-Fi stuff manufacturers, have made this group, and they give recommendations. So they saw that web was completely fucked, and so they said, well, we have to do something. So because they are also involved in the IEE, they try to extract some transitional work from them to propose something better. So this something better is WPA. So WPA just replace everything. So it's changing the authentication scheme. So the new authentication scheme can be based on pre-shared key or .1x authentication. So it's pretty strong, and the main thing of this is the key that will be used for ciphering will be different at each association. So that's the main point. So they have a new key generation and scheduling scheme, which is pretty strong. We can say this. So the main thing is key renewal for every association. So on the same network, every client has a different key. And a new integrity check, so which is SHA-1 based. So it's not so strong, but it's okay for a wireless network within the given time of association. So it's pretty solid, and it can prevent injection replay. Because when you calculate the MIC, the MIC, you will introduce a sequence number. So each frame is sequenced. So if you try to inject, you will have sequencing problems. If you try to replay,